Example 3, let's do part 1 together. Our questions are, is it linear? If it is linear, describe it and write an equation. If the relation is not linear, how do you know? So right in the beginning here, we have this table. We can plot these points. And remember from the previous example, if those points lie on the same straight line, then our relationship is linear. So we plot the point 1, 4. We plot the point 2, 6. We plot the point 3, 8. And we plot the point 4, 10. And then finally 5, 12. So we grab our ruler, our straight edge, and we can put it all along these points. And I can take one straight line and connect all of those 4 points if I needed to. So I can look at that relationship and say, because those points lie on the same straight line, then our first question, part A, is yes, it is linear. Let's grab our pen. A, it's linear. Part B, if it is linear, describe it and write an equation. Our description goes back to the same sentence every time. I look in my table or I look on my graph. As the x values increase by 1 each time, all of these add 1. 1 plus 1 is 2, 2 plus 1 is 3, and so on. This is a consistent increment. We're looking for the same on this side now. Between 4 and 6, that's an increment of 2, an increment of positive 2, positive 2, positive 2 each time. This increment is the same. So when we describe it, we would write the sentence as x increases by 1 each time. Y increases by 2 each time. It's the each time that's important. If this was any number different, 2, 2, and 3, then I would say no, this graph is not linear. There's not a consistent change on both sides. And I know it's linear because the points all lie on the same straight line. All right, we have to write an equation. So our equation comes from, what is the increment in this dependent variable? Well, it's 2. So that tells me when I write my equation, I need to write y equals x is getting doubled each time. Then I need to figure out this constant term. If I double 1, 1 multiplied by 1 is 2. I need to add 2 to get 4. Does that relationship work with every number? 2 multiplied by 2 is 4. 4 plus 2 is 6. 3 multiplied by 2 is 6. 6 plus 2 is 8. So the number that I multiply my variable by my independent variable is, if it's linear, always this consistent change in the dependent variable. That's where this 2 is coming from. Then I have to do a little bit of work to figure out what needs to be added or subtracted to result in each of the y values in that table.